Hello. We are going to build chatbots with additional skills and plugins today. This is a continuation of our Sydney chatbot that we've been experimenting with last week, except now we're going to enable her with more skills. Recall last week when we built this Sydney bot. The Sydney bot has an interactive interface in command line. So as you can see, this interaction was okay. And when it returns, it will give us something quite reasonable, give us some suggestions from around the Bay Area. And then you can quit. So what we're going to do today is we are going to create a brand new project. And let's call that, we're going to enable Sydney with additional skills. Okay, now that we have the directory copied over, let's now open up our code editor. First thing we're going to do, because we're going to be making Sydney real, is we would like to create a brand new Sydney chatbot. So let's call it chatbot. Let's copy over everything that we have done into this new chatbot. Now, first thing we wanted to replace, though, is using the semantic kernel way to do .environment variable is a little clunky. So instead of that, we're going to instead go back to use a much more convenient python.inf. And then rather than doing this very clunky assignment, all that we need to do is to do a low inf and then find.inf. And then we are basically done. All right, let's reorganize a little bit our code here because we're no longer using command line. We're going to use a chainlet for this work. Let's move the name of our bot to the top. And then let's also import chainlet as CL. And then for the chatbot model, right, we're going to be specific because we'll also be using a text completion model later. So let's also add that in. So the difference between a chat model and a text completion model is a chat model accepts messages or lists of messages, and a text completion model accepts basically any text blob. And so in this case, there is a ChatGPT 2.5 version called the instruct completion model. Okay, with that said, we are done here. And rather than using the semantic kernel, we are going to now use the environment that we have set using our .inf file. And we're going to load in the OpenAI API key. And then we need to update the names for the chat model here. And we don't really need organizational IDs. I'll remove that. Let's clean up this area a little bit so that all the import statements are together. The bot name is Sydney, and I forgot to actually instantiate a font.inf. And then we're now ready to go. So let's come back here. We created a context. We created the semantic function. To save on tokens, let's reduce our maximum token to 1,000. And then now we are able to get rid of this asynchronous run because we're going to use now chainlet. So how do we do that? So we need to define two functions. The first function is on message, and this is an asynchronous function, and our usual convention is called it main. It takes in a query from the user from command line, and then we will need to fill that in. The second function is on start, on chat start. And it's also an asynchronous function. And let's call it start by convention. As we have done in the past, let's await on a opening message that we're going to send to the user. And then we're going to send it after we filled it in with a nice greeting. Hello there. I am Sydney. How can I help you? Okay, that sounds pretty cool. And then now, because we got rid of because we no longer manage this session, we leave it to chainlet. We can remove this entire method. Same thing for interacting with Sydney. Instead, we're going to move it into the main method. Okay, so now that's pretty cleaned up. Let's give this a try within implementing the main method. So we know that eventually we will need to await and send the message to the user where the content is some response that we're going to be retrieving from the large language model. And the response here initially would be some empty string. And the response ideally would, after we tested it out, there could be errors here. So let's do a try and accept clause here. Except on exception as E. And the response could be cannot proceed due to some error. But the most likely response would be whatever the chatbot, a chat function that we had created, which is here. And we pass the chat function the user query. Let's give this a go. All right, let's see how many bugs have we created so far. So we're going to do a chainlet run within the SRC folder, the chatbot -w. -w stands for it will reload whenever we make changes to the source code. First thing we notice, our chatbot name is not instantiated. Okay, so we'll take note of that. There's one bug there. We're going to change. I am well. And you? There is something that is messed up. Let's look at the issue here. So from our log, it seems like we are outputting a semantic kernel context, which is not a string. Okay, all right. So let's go and fix both of these two bugs. First bug, we forgot to turn this into an F string. That's an easy fix. Turn that into a bot name. Second is that we are told from our command line that this is not a string. Okay, so let's turn that into a string. And then one more thing I realize, by default, the input string name should be input, not user underscore input. So let's change that back. That's a convention within the Microsoft Semantic Kernel. Okay, let's save that and bring our chatbot back. Okay. I am well. How are you? Okay. Can you tell me the meaning of life? Wow, it is a philosophical question indeed. So it's working out well, okay? What is 1 more than 10? Well, 1 more than 10 is 11. Okay, that also seems right. All right, looks like our chatbot is working. So it turns out rather than simply turning the chat function's output to string, the way to extract the actual string out rather than using the casting is to use this additional property called .result that should get back from the chat function the response from Sydney. So far, we have simply created a very simple chatbot, if you may. And the chatbot is interacting with the user via a web interface and intermediating to the large language model. So it turns out there's another way to actually consider this. Any given agent or a chatbot could be interacting with a variety of different large language models. And in the parlance of semantic kernel, these are called large language model connectors. There are 3 main connector sets that come bundled with the default semantic kernel. These 3 connects your chatbot or your application to 3 types of large language models. First are those from OpenAI, the most popular ones, and arguably the highest quality. Second, those that are from Azure that are wrapped around the OpenAI large language models. And third are all those that come from Hugging Face. And each of these type of connectors allow you to do 3 general types of functions. First is to chat. Chat is basically a sequence of messages passed between the user and the large language model. Second is text completion. These are not necessarily chats. These are much more in the traditional, given a series of text, what would a large language model do to complete it? Third are what are called text embedding generation models, and these would encode any natural language into multidimensional embeddings. And we'll be demonstrating how to make use of embeddings when we are going to cover memories and how to do local retrieval to augment an existing large language model shortly. Let's now take a look at how to find out what are the registered text completion, chat, and embedding services that exist within the semantic kernel. Let's now create a notebook for us to do this. And let's call this is our large language model query service. And it's an iJupyter notebook, IPython notebook. So let's open up with a quick comment. So these are large language model queries. And let's do a first one. Let's try out for the coming semantic kernel here, which we need to instantiate. Let's now import semantic kernel as SK. And let's create a kernel. Select the environment that we wanted to execute. Okay, now that we have a kernel, let's take a look at the first text completion models that we have. So these are our kernel all text completion services. We need to copy this. And let's also look at not only text completion, but also look at the chat completion and the text embedding models. So kernel dot all of the different chat services. all chat services. And then lastly, kernel.all text embedding generation services. And as you can see, because we have not registered any, all of them are empty right now. So let's show how to register a chat service. So let's open up our Semantic Kernel connectors, right? So all of these are connecting to the large language model, and we want AI connectors. In particular, we're going to use OpenAI connectors. Let's import our, there are a number of such services we can create. So the first is OpenAI chat completion model. And then just also so that we understand there are more than just chat, let's also import the text completion model here. And then let's create one. Here's a chat service. The way to register such a service is within the kernel, we want to add a chat service. This is now how we register. And the first thing we want to do is to create a service ID. Service ID is a unique string, and it is, as long as it is unique within your application, that is fine. Second is you would like to create the actual service itself. So the service is the library that has been provided from the semantic kernel. We call it the OpenAI chat completion service that is up here. Let's open it up, and we need to put in the usual. We want to identify what is the exact model. So in this case, we could say this is our GPT 3.5 Turbo. And then we need to put in an API key. And for this API key, it's going to be some key that I'm going to just randomly put in, because I just simply want to register to show you how this actually works. So let's save that, execute. So it's now registered. Let's now take a look. When we look at the printing of these services that are registered in the kernel, what that looks like. Let's copy that, paste, return. As you can see now, our chat completion model has been registered as a chat completion. And then also this service is also registered under text completion, because anything that the chat completion model can do, it can also do completing a text, assuming that the input is in a sequence of messages. All right, so hopefully that demystified for you how to create a service. Of course, this currently would not work because this API key is randomly generated. This should be retrieved from your local environment instead, from a key that OpenAI has provided for you. So what we are going to do now is we're going to create new skills for Sydney. And for the sake of illustration, right, we want to create Sydney who is able to write poems in the style of Shakespeare, as well as, let's say, Robert Frost. Okay, so right now, if I, Sydney, hello there. How is your morning? The response is, frankly, not inspiring, right? We want the response, even if it is negative, to be very inspiring. All right, so now we need to change the way that our chat function operates in order for Sydney to respond in various poetic forms. So rather than a plain vanilla chat prompt, so let's go and change this chat prompt to the Robert Frost prompt. And the input from the user would be the same. Let's say the user would like a prompt about writing a love song, for example. And so what you wanted to enable here is to have the prompt indicate you want it to be in the Frost style. So the Frost style is simply nothing more than we are telling the large language model to rewrite the above as a poem in the style of Robert Frost. Now, the function that we are creating, the semantic function, right? So let's update the name of that to make sure that we are creating a Frost prompt. Whoops, changed the wrong one. So let's call this, we are creating the Robert Frost function. And the prompt it's inputting is the Robert Frost prompt. So it's generally good practice to give the name of each variable that you're putting in so that you know that you're not substituting the wrong one. So the first one here is the prompt template. And we have just created the Robert Frost template above. And then we're going to give it a name, a service name. Let's call this a function name. And this is our Robert Frost function. And then we're going to give it, for this function, going to give it a particular skill. And the skill is, well, Robert Frost writes more than just poems, right? So this is the Robert Frost poetic poem skill. And then we want to give it a description. So the description is incredibly important. This is where we are telling the large language model when to pick this particular function given a user input. So we want to give it a very descriptive name, such as create a poem in the style of Robert Frost. And then, of course, we have maximum token and setting the temperature. Well, we don't necessarily want to be incredibly creative here. So maybe let's tune it down to 0.7. Okay, so this is the Robert Frost function. Similarly, we could just copy and paste this and create the second skill, which is rather than the Frost prompt, this is the Shakespeare prompt. And similarly, we don't want this to be a plain vanilla input and output. We want to rewrite the above as a sonnet in the style of William Shakespeare. And then for the Shakespeare prompt here, we want to create a similar function called a Shakespeare function. And the function here has a function name. We're going to call it Shakespeare. As long as it's unique, it's okay. And then this is the skill that we are creating within this function is a Shakespeare sonnet skill. And then similarly in the description, we want to write a sonnet in the style of William Shakespeare. Okay, similarly, we want maximum tokens to be no more than 1,000, temperature to be 0.7. Okay, now we have created two functions, Shakespeare function and a Robert Frost function. How do we use it? Well, the way to use it is also an opportunity for us to introduce a new concept, and that's the concept of a planning tool. So when we talk about planning, we want to see exactly how the large language model decide which of the many skills it has available to it and how does it chooses which one to use. Like in other words, just like human being, we plan. And so we're going to use a basic planning function first. And so we first need to open up and include from the library, from the semantic kernel. And not in the connector module, but in the planning module, we want to include a basic planner. And then coming up in the next few videos, we'll go through other than basic planner, also stepwise planner, linear planner, etc. Okay, so for a basic planner, so we wanted to replace this black box called a chat function with specifically how we plan to select which skill to use. First, let's create a planner. Second, rather than the response being from the chat function directly, let's be very explicit on what is the plan that we are going to be creating. So planner.createPlan async, given the query and the semantic kernel, we want to create a plan. So, and then in the response, rather than outputting from the chat function, we want to also await for this asynchronous result from the planner through executing the plan asynchronously by passing in the kernel itself. Now, once this is respond, I need to check whether the output needs to be .result, but we can check that in a second. So in the meanwhile, let's also print out in the console what the plan is so that we could actually check it out to do anything sort of debugging. So we want to do the plan.generated plan so that we can see what it is that the large language model has decided to do. Okay, that looks pretty good. Let's save this and give this a go. All right, now that our new chatbot, Sydney, empowered with both Robert Frost as well as Shakespeare skills are now reloaded via this chainlet application front end. So let's ask it, hello, Sydney. Can you write me a love poem? So first of all, because between Robert Frost and Shakespeare, we have indicated one of them to be more about writing love poems. So we're going to ask you to pause and think about which style would this query be returned as. And then we'll look at the command prompt on the side so we can actually look at this together, okay? So let's open this up. This is the command prompt. And we're going to return asking Sydney to write a poem. And the love poem that has been selected is the Shakespeare sonnet skill poem. And as you can take a look, oh, what divine and tender love I feel, a flame within my heart, so strong and true, etc. So that's indeed a Shakespearean sonnet. Now, similarly, can you help me make a life decision? Now, if you have read Robert Frost's poems, right, his very famous poem on a road diverged should remind you that perhaps if the large language model is paying attention to Robert Frost's poems, this should come back as a skill that is going to invoke about Robert Frost. Let's take a look. On the left-hand side, there are two functions that it has discovered, and it actually did not make a decision on the specific skill that we invoked. So that's too bad. So the way that this works is we'll come back in here and look back at the skills that we have created. Most likely, it is because this specific description for Robert Frost and this description for Shakespeare did not let the large language model decide that both of them are relevant. So let's augment this. And this gives us an opportunity to introduce to you why writing the description is so important. So we want to augment this description to be write a life skill poem in the style of Robert Frost. Okay, let's see if that is sufficient. And then similarly create a love sonnet so that we can differentiate between these two skills. Okay. All right, so in the two styles of poems that we wanted, Shakespeare is about creating a love sonnet in the style of William Shakespeare. And in the style of Robert Frost, we want to create a poem about making decisions. Okay, so let's see if we could invoke these two skills by the right kind of decisions that come in through Sydney. All right, let's see if we could invoke Sydney to help us write a poem. Okay, hey, Sydney. Can you write me a love poem to my prom date? And then we're going to look on the left-hand side here. We're going to see that it has invoked that the Shakespeare skill is the most relevant here because it's about love. And there it is. To thee, my dearest prom day, I declare a love so true, a passion fierce and rare. In beauty's grace, thou dost forever shine, etc. That sounds pretty good. So now let's, hey, Sydney, can you write me a poem on how to make a decision on where to go for college? And what we wanted to see is that it has invoked the Robert Frost skill. And indeed, when this comes back, we should be seeing a Robert Frost poem style. Two roads diverge for college, and I stood there pondering with an anxious sigh in the style of Frost. I shall now convey, etc., etc. That's pretty good. All right. So what have we done here? We have introduced to you how you can create your own custom skills, and the skills are in the form supported by a specific prompt and instantiated or hydrated with specific parameters like number of tokens and temperature. And that is a pretty powerful way to extend the ability of a large language model. And we will continue down this path in the next few videos to show you how to expand the skills and the plugins for a large language model so that we could get a human agent-like chatbot experience.